This video is the beginning video for scientific notation, and all I'm going to discuss here is the concept of scientific notation. The next video I'll actually go into using scientific notation and doing applications using scientific notation, which is really the useful, where scientific notation becomes very useful. We need a couple prereqs here. You need to know about the laws of exponents, all of them, and you also need to know about integer exponents, both negative and positive exponents. Numbers, exponents like -3, -2, -1, 0, 1, 2, 3, and so on and so forth. We first begin with a conceptual definition of scientific notation. And like all conceptual definitions, there's some flaws with it, but this is for you to get a kind of an idea of why we use scientific notation, what scientific notation actually is. Truthfully, scientific notation was created so that we can understand what a number is without reading the number completely. It's a way to express a number, and usually this number is either huge or really small, in some easier to read format. And this easier to read format involves a number between 1 and 10, including 1 but not including 10, and a power of 10. What do I mean by that? Well, it means that you have a number like 1.123, that's definitely a number between 1 and 10, and then it also includes a power of 10. In other words, I'm going to attach this times some power of 10, let's say that. Or 1.118 times 10 to the, it could be a negative power of 10, like a -5. Or 8.3122, well, now I wrote a 1, I'll just leave it a 1, 7 times 10 to the -301st. Or, and I can go all day long. Notice that each of these numbers that hang out front here, that I've written, this one, and this one, they're all numbers between 1 and 10. So even 9.999 times 10 to the 8th is still considered a number in scientific notation, because the number out front, what we call the mantissa, is a number between 1 and 10. It doesn't include 10. You cannot have 10. So let me just show you one that's not like this, 10.01 times 10 to the -3rd. That's not in scientific notation, because this number right here is greater than or equal to 10. So that is definitely not a number in scientific notation. And while I'm talking about it, nor is this. 0.999 times 10 to the 5th. That's not in scientific notation either, because the number out front is not between 1 and 10 inclusive. So, got to cross that out as well. So why do we have scientific notation, and really, who uses it? The answer to the second part, who uses it, is pretty easy. Everyone. Everyone, even when you read the newspaper, newspapers actually use scientific notation, sort of. They use a kind of a manipulated form of it. When they tell you, for example, at one point the national debt was 9.8 trillion. Well, when they say 9.8 trillion, that's a form of scientific notation, a very loose form of scientific notation, because it doesn't say times 10 to a power, but it's very close to the form, because if you look at this number here, that number is between 1 and 10. And I could write a trillion actually as a power of 10, so we'll talk about that in a different lecture, in the next lecture. But for now, whenever anybody says, oh, you know what, that guy has $8.1 million in his bank, or that house is worth $1.5 million, or something like that, when they use that 1.5 or 8.5 or 3.7 or anything like that, that's when they're using scientific notation. Now, why do we have scientific notation? Well, that's a really good question. The reason why we have scientific notation is because, well, often numbers like this are very difficult for people to read. Also, numbers like this are very difficult as well, because we have to count zeros and all this stuff. But when somebody hands me this number, there's just a lot of extra wasted space on this page, a lot of a lot of space and time was wasted in writing all those zeros. So often people will just write this as 9.8 times 10 to a power. And actually the power on this one would be 12. But I'll tell you why I know that in the next lecture. But the fact is, this is a very nice compressed form of this number. Also, this smaller number down here, it's a very teeny number, right? 0.0000000121 can be written in scientific notation as well as 1.21 times 10 to the negative ninth. Now again, I'm not telling you why it's written that way yet. I'm just telling you that it can be written that way. And if I have a choice of writing these numbers as these long forms, what's called standard form, versus the scientific notation, I would prefer the standard notation. By the way, that's called standard form or standard notation, honestly. And this is called scientific notation on the right-hand side. But I prefer scientific notation for these huge or very small numbers. And by the way, once I get a number in scientific notation, I could perform the same mathematics on it that I could with these larger numbers. I'll show you in the next lecture. So that's the concept of scientific notation. You take a huge number or a very small number and you write it in a compressed format. And that's exactly what we want to do.